In this tutorial, we are going to take a look at how to do integration by substitution. And this can be kind of tricky, but once you get your skill set strong enough, it's actually really cool. So let's go ahead and just jump in with a problem. Okay, so here's our problem. We just want to take the integral of 1 plus 2x quantity to the 4th power times 2 dx. Now, this is not an easy problem to do just by basic integration. In fact, it's near impossible. Unless you wanted to multiply 1 plus 2x out 4 times, multiply that all by 2, and then take the integral. We are going to try a more sophisticated way of doing that, and that is called substitution. And it's sometimes referred to as U substitution because we typically use the letter U to substitute with. So we kind of have to do some side work here. And I'll explain as to why we use the parts that we use as we go. So I'm going to go ahead and tell you real quick just what our substitution is going to be. And it's going to be this piece right here, 1 plus 2x. So off to the side, I'm going to make sure that I let myself know that u is going to be 1 plus 2x. Now, whatever you choose u to be, you then have to go ahead and determine what the derivative of that is. So we're going to say du equals, let's see, what is the derivative of this? And it's 2. And this is technically du dx is equal to 2. Now I can transform that very easily by saying du is equal to 2 times dx. So let me show you real quick why I chose to use 1 plus 2x. Whatever you want u to be, when you take the derivative of it, you want to be able to find as many pieces here as possible back in the original integral that you started with. So here, if you look here, I have a 2. Okay? When I look back over my original problem, I see that 2 right here. So it's covered. My u substitution is going to cover that piece, so I don't have to worry about it. Also, the dx part, well, that's right here, so that's also being taken care of. And then 1 plus 2x is going to be replaced by a u. So all the parts here are actually covered. So it's my new function is going to look like this. It's going to be u to the 4th power, and then 2 dx is the same exact thing as du. Now, if this was my original problem, this would be extremely easy to integrate, and that's why we do substitution like this. So after we go ahead and do our substitution, excuse me, let's go ahead and integrate as normal. So that's going to be u to the 5th power over 5. Or, an even more sophisticated way of doing this would be 1/5 u to the 5th power. And then, of course, since this is an indefinite integral, we need to attach a plus c off to the side for any constant that we may have. So, we have to make sure that in the very end, we just make sure that we are in terms of whatever variable that we started with. And in this case, it was x. So I have to go back and replace u with what I originally had. So here's what my answer is going to look like. My antiderivative is going to be equal to 1/5 times 1 plus 2x, because that's what u was, to the 5th power plus c. So that's how I'm going to take care of that. Pretty easy, and it's really cool. Let's take a look at another one. Okay, so here's our next problem. Now, once again, if you take a good look at this, this would once again be kind of a nightmare to do by simple distribution and factoring. It wouldn't be impossible, but once again, we want to try to be a little bit more sophisticated here. So, once again, we're going to use our u substitution because it looks a lot harder than just a normal rule that I have. So off to the side, I'm going to go ahead and get u ready and my du. So I want you to just take a look at this problem before I fill in anything. And I want you to pick the part that you think would give me the derivative of a lot of the terms that I'm left with. So think of the term that you think would be good for substitution because the derivative takes care of a lot of the other parts. So just pause the video and think about it for a second. What would you use for u? And the correct answer here is going to be x to the 4th power plus 3. And let's take a look and see why. When I take the derivative of this function, I get 4x cubed dx. Now, this part is the part that's covered in u, so I don't have to worry about him being covered by the derivative of this. So let's see here. Let's see if I can find this x cubed guy. And I do right here, so he's covered. I also see the dx, which is here as well. So what am I going to do about the 4? I don't see a 4 anywhere in here except that exponent. Well, we have a way of doing that. When you rewrite your integral and you do all your substitution, I want you to think of what we'd have to multiply 4 by to cancel it out altogether. And the answer is 1/4. 1/4 times 4 gives me 1, and that would cancel that out. So whatever you need to cancel it out, you just put it in front of your integral sign. That's all you have to do to get around that. So my substitution, since the x cubed and the dx part are taken care of, this is just going to be u to the 2nd power and then du, since that's what du is equal to. It's equal to that x cubed and the dx. And then that 1/4 is going to cancel that 4 out. So let's go ahead and integrate. This is going to be 1/4 times, this is going to be u cubed over 3, and this is indefinite, so we need a plus c. So let's go ahead and clean this up real quick. This is going to be the same thing as 1/12 times u cubed plus c. And even more simplified, we need to replace u with what we had it with to begin with, which is x to the 4th plus 3 cubed plus c, and that is our antiderivative, or capital F of x. And that's how we do integration by substitution. And that concludes this tutorial.